I told her the moment that I approached her, come closer, I needed a little closer. Heart colder, I'm looking over my shoulder. Then I showed her something to make her come over.
What's good, y'all? What's good, man? Today we're gonna be working on something really important for engineers, really important for people just understanding circuits in general. Altogether, this is more so geared towards engineering majors, but if you were interested in just understanding series and circuits as it relates to power in your home and different things like that, we're gonna work on essentially everything. Pretty much try to cover the whole topic in 20 minutes and do what I do best in the channel, which is pretty much just explain everything you need to do. Sorry, I was trying to see if I could get a good pan of me working for you guys. So essentially, we're gonna go over the Ohm's law pie chart, understand what it is, how this could be a small cheat sheet for you. It sort of looks like, your trig type of pie chart with some different things. So this is really important. The most important thing I want to say is a lot of people, when they're starting the work, they know the formulas, they try to remember it, but sometimes they make a simple mistake in understanding what's the difference between series and parallel circuits to begin with. So when we read the definition, right, when we're looking at the definition, we're basically trying to understand like what's the difference between a series and a parallel. So they're both essentially in a closed circuit, but parallel essentially makes you be able to branch off in different ways. So the easiest way that I can break this down here is that let's go and think about a street, right? So we have one side, we have this road here, right? Say this road here is Main Street. Okay. Sorry about that, guys. Y'all know I'm still getting used to this pen. Main Street. Okay, cool. Now, what a series tells you in a circuit is that everyone has to go down this road. Everyone, every single car. This car, that car, this car, that car. So right now we're on Main Street. Like you're just going that way. Because everyone's gonna have to go that way. What circuits tells us when we're thinking about a parallel series is we end up having a road that diverges. So we have a road that goes here and go this way. Let's see. We have a road that could go this way. Okay. So branches off. So now we have some people that can make a left turn upon here. We have some people that can make a right turn upon here. And obviously we have some people who can go that way. Right? Same concept. People are going up that way. But there's that fork in the road, right? There's like that meme where you decide like, do you want that crazy 10 out of 10 person who cares about you and is loyal but is insane, or someone who's mischievous and like a cheater but they're chill and you guys connect and everything. So that's the fork in the road that we're discussing. The next thing that we're gonna bring up is trying to understand like before we even work on the actual math. I think it's a good time to pause and think. Look at question 6. Would you describe the one on the left as series or parallel, or would you describe the one on the right as series and parallel? So go ahead and pause the video here, and I'll go ahead and come back and let you know what it is. All right, so by now we should have went over this question and see. So this one is pretty easy. This one is pretty easy here. Looks like it's in series. It doesn't have the same start point and end point, right? Like where we have the different branches as well, same thing. This here on the right though, this is series 2. See, sometimes it gets like a little bit tricky where people are like, oh, but there's these three things here. Like, shouldn't they connect? Isn't that the way that isn't that the way it is? But no, we have to remember that the reason why this circuit is a series is because it leaves the battery, right? It leaves the battery on the right, leaves it here, and it goes through R1, goes to R2, goes to R3, then goes to R4, and then returns back to the battery, okay? So we're seeing this dialogue in this occurring. And there's only one single path, like, turning up this way. And the current can't split. So it must go through each resistor one after another. Like if it would have branched off here possibly, but you guys get what I'm saying. So the reason why it's not parallel, and remember, for a component to be parallel, two things must be true. They must share the same exact start point and end point, okay? So that's what it is. And you just have to think about it pretty much simply like that. So right now what we're going to go ahead and do is use this pie chart to try to understand how we can answer some questions right here. So I'm going to give you guys about, say, 5 minutes. No, actually, I'll give you guys about 6 to 7 minutes. About 6 to 7 minutes to work on this problem here on the left. And go ahead and pause the screen. And when you all come back, we'll go ahead and work on this together. All right, so by now, hopefully you guys, pause the screen. We're going to go ahead and break this question down with everything that's pretty much needed to know for it, okay? So, what's the first thing that we're looking for? Our RT, our big R. What is that? Our resistance, okay? RT, total resistance, right? So, we got our two R's here, two R values. So, we're going to go ahead and add them up. But some people always forget to do this. Remember, we have ohms here and we have kilo ohms. We want to turn these kilo ohms to ohms. So what are we going to do? We're going to go ahead and convert. So the first step that we're going to do right here is we are going to write our 560. Guys, I got to bear with me, man. I got to learn how to do this a little bit better. Hey, man, like they say, man, everybody good at something. Fortunately, that's not it for me, but but yeah, we're gonna do 560. Oh, that's much better. Cool. Plus 1.1 kilo ohms. So what does that turn into? 1,100. So we're left with 1660. Okay. Ohms. Don't forget your units. Perfect. So that's our total resistance. So now let's go back to the previous question. Now we're going to find I. What is I? Let's think about it. Don't forget to go here. Remember, our amps, right? Don't forget. Another thing I really want to say that's really important is when you put your answer, remember your units, what units you're using, okay? Remember what units you're using. So remember, try to remember this pie chart like, you know what I'm saying? Remember this pie chart like it's that new TikTok song, you know what I'm saying? Remember that pie chart like that new Biba Doobie song that came out or NBA Youngboy song that came out. Like, you want to make sure that you're really in tune with this, okay? So now we're going to find our IT. Well, we know T is total, right? And we know our I is known as current. So we're going to try to find the total current. Now, what am I doing when I'm trying to find total current? Well, let's go ahead and go to our sheet, right? So what am I trying to do when I'm trying to find like my current here? Well, we have our I amps, right? We have our voltage, right? We have our voltage of 6. And then we need our resistance. Dang, but where is that? Oh, wait, we just solved for it, right? We got it already. So now we're going to go ahead and come here, come back down here. And what we're going to do is our IT will be the 6 volts will be those 6 volts divided by that 1660. And what will that give us? So I'm going to go ahead and pull out my calculator here. We have 6 divided by 1660. You have about 0.0036, right? But remember, what value? What value are we in? Amps, right? So we're gonna have 0.00361 amps, amps, right? Which will be how many milliamps? Remember, milli, 1,000, 3.61, okay? Milliamps. So now we have our first 2 answers here, all right? We got our first 2 answers. This is lovely. So we got our first 2 answers of 1660, and then we also have our next answer of 3.61 milliamps. So now we got VR1 and VR2. Well, we know now we're trying to find the voltage. We have our 2 resistors. Pretty much they're doing the same thing, right? It's connecting. It's in series, right? You got to go through that way. You got to go that way. You feel me? So what you're going to do right now is you're going to try to find how the voltage drops. Now we have to think about what formula am I trying to find when my voltage drops? Like, what exactly am I doing? Well, when we look at the chart, right, see, we're trying to find volts. Awesome. So now, do we have power here? I don't see no power. Do we have power? No. So, bet. So we know we don't need no P. And we not pushing P. You know what I'm saying? We ain't pushing P here. We pushing I and R. So we gonna have the current, man, times the resistance of each resistor. So I think this is the point too where things can sometimes get tricky. Remember, it's V of R1, right? So it's where the voltage drops within that resistor. Remember, it's not VR, right? VRT for our our total resistance of the resistor. We're looking at each specific resistor and how the voltage drops. So that means we're going to use our current, right? We're going to do our voltage, V, R1, sorry about that, VR1 is equal to 0.00. Yo, guys, telling y'all, just give me a week and I'll be much better on this, man. Feels so weird like writing with the digital pen. Apologies for that. But okay, awesome. We're gonna do 0.00361 times, what was that first resistor we had? 560. That value there, right? So you're gonna do that for R1. This will give you the value of R1. And then the voltage for R2, what would you do? Same thing, 0.0361 times 1,100. Remember, that's that 1.1 kilo ohms. That would be R2. So for R1, gonna put this in my calculator. You should get around 2.02. And then for the next one, you should get around 3.976. Now, its voltage drops against both of these. So what are we expecting our answer to be? Voltage drop, right? What was in that chart that I showed you guys? Volts, okay? I'm assuming you got it right, but if you got it wrong, it's okay. I'll show you here. Looking at volts here. So that should be your answer. So we're almost done. We've done 4. Let's do our last 3. Let's shoot our last 3 out. We're looking at P. We're trying to push P now. You know what I'm saying? We're pushing P. So we're trying to find a power in each resistor. So now what do? We look in our chart. We're looking for our power. Looking for our power here. Okay, cool. So we know that we have our voltage, we have our resistor total, we have everything here, right? So now we're deciding what is it necessarily that I have to do to find the power in like watts for what I'm using. Well, remember our IT, right? Our IT value, which was our 3.61 milliamps or 0.00361 amps, is essentially what's fueling in this formula. So remember, your power here, you want to take that current squared times R. Okay, you want to take that current squared times R. Okay, what does that mean? That's telling you to take that 0.00361 milliamps and square it, right? And multiply it times that resistor again, okay? So let's break it down, because this sometimes gets people like a bit confused. So you have your power, your P for R1, and then also your P for R2, right? But let's go slowly step by step. Your PR1 should be your I squared times R of that specific resistor. So this would be R1. Now our R1 was 560. What was our I squared? Our I squared was 0.0000361. What we're going to do, we're going to square that. And that's going to be equivalent to our power of the R1, okay? This is a really, really important idea and math thing that sometimes gets a little bit like daunting, is the fact of understanding when and where do you use what formula, right? So when we think about it, and as you guys can see, I wrote it down here. Our power for R1 is our I squared times R here, okay? That's where we're getting it essentially. So what I want you guys to do is to be able to understand that you're trying to find the power in each resistor. Hence, right? Power of each resistor means that you have to respect each one in which it drops, right? In which it drops. And what did you do last time when you're trying to find where the voltage dropped? You use your current value. Okay, so you're squaring it now. Cool. So now PR2 for everybody should be relatively easy. Our PR2 should be 0.00361 squared times 1,100, right? And we should get about 0.014. Oh my goodness, man. I almost want to say something else. We gonna get 0.0144 watts, which is equivalent to 14.4 milliwatts. Now, last thing we gonna do, PT. By this point, if you don't know what that T standing for, you're cooked, buddy. Just kidding. This is our power total. So how are we gonna find our power total? Let's go ahead and go back here. Let's see, we find our power, right, for total. What y'all gonna do? What we just did. Our I squared times R. But remember. I cannot stress this enough. Your R will tell you where you're using it and what you're doing. Power in each resistor, it told you PR1. So what are you doing? You're just doing current. I squared times R1. I squared times R2. I squared times R3, R4, R5, whatever resistor it is, right? But now because it's total power, what are you doing? I squared times RT, okay? So remember, it is key to understand that when you denote whatever of the four major categories you're using, you want to make sure that you know what your subscript is saying, okay? You want to make sure you understand what your subscript is saying. So we have our PT here, our power total. So it's going to be as simple as going here, doing 0.00361 squared times 1,660. Remember, this was the ohms value, and we end up getting 0.0217 watts, which is equivalent to 21.7 milliwatts. Okay, so that was a lot of work. It's much easier and simple, you know, to rush through it, but I really want to take the time to understand and follow a lot of the things that we have here in the ohms chart. Definitely want you guys to work on what's here on the right side whenever you guys have a chance. But just wanted to leave you all with the fact that circuits can be difficult, especially when analyzing series resistance and, you know, determining the requested information based on how it looks. But it's pretty much breaking it down, understanding, am I in series, am I in parallel? Remember, am I going through that same road? Am I starting from that 6V, going down to that 560, that 1,100, and coming back to where I'm at? Or am I splitting down the road where I could like go here and go there and move up the road, right? So that's number one important thing. Then when you're there, pretty much just following the formulas. And the next thing is to understand your denotations. Remember your denotation of your major letter, your capitalized letter, and then your subscript, okay? Your subscript is going to essentially tell you what part of that resistor, what part of that current, what part of what you're using, right? Usually a cool denotation is you're going to know which resistor is going to use, because it's going to say R1, R2, R3, R4. You're going to use it that way. T, obviously total, you know what I'm saying? So these are small things that people need to definitely keep in mind and keep in play when we think about circuit analysis. But just leaving you all with that, and I hope you guys have a great evening. Okay.